thank you for nice introduction of me. My name is Sasaki. I already in my career was introduced by Professor Lee, so I skipped my self-introduction. But I also very appreciate Professor Lee to give me such a chance to provide this kind of the seminar. Actually, phosphorus issue, so-called, is very important, as well as CO2 issues. But most of the people did not aware of this. So I am very happy to use this presentation to the student. All of you understand what is a phosphorus issues and how important it is. If most of them can understand this importance after the seminar, it's my great pleasure. So now I try to move to the presentation. So as already mentioned, at this moment, we have several big programs. One of them is so-called CO2 issues, energy issues, and resource issues. Typically, resource issues is most of them may have so-called rare earth metal programs. Now we are facing the very hard time to get rare earth metal. In the same way, phosphorus also soon we may not get. So to understand this situation, it is very important for the future preparation. So first of all, to go to the details, I suppose most of them may not familiar with the phosphorus itself and also the phosphorus issues. So at the first stage, I briefly introduce what is the phosphorus and what is the phosphorus issues. Then you may easy to follow the detailed explanation. Just as shown here, the phosphorus is a very critical element for life. Without phosphorus, we cannot live. As well as not only our life, society itself also cannot stand without phosphorus. There is no alternatives. It's a very indivisible element. And then all of the phosphorus actually come from so-called phosphorus rocks or phosphorus ore. So most of them was initial origin of phosphorus is phosphate ore. And very interestingly, this phosphate ore is very unevenly distributed. About 71% of the phosphate ore is in Morocco. And other countries, very small amount of deposits, they have less than 5%. So many countries did not have phosphate ore. So very, in the sense, bit uneven distribution creates trade problems. So many countries cannot get many of the phosphate ores. And also the phosphate ore is, at this moment, mainly used to food production. Actually, it is to produce fertilizer, it was used. And you can see in the parts, some of them used for animal feed and some additives. So it is very important resource for our life. But on the other hand, phosphate is also have some role as a pollutant. You may have, once we use a phosphate contains detergent, it's run away through the river to sea, and it's becoming, because phosphorus is very good nutritious, so many algae are developed, so all of the inland sea was deteriorated. So phosphorus has two phases. One is very important resources, and another side is work as a pollutant if it's overused. And another interesting is, so we call the phosphorus peak, like oil peak. Many researchers simulate how long we can get the phosphate ore. So most of them, sometimes many of them, the result is actually similar. Now is with year, the production amount is gradually increasing. And at some time, depend on the researchers, someone says 2030, 2070. Anyway, it's reached the maximum peak, top, and then start going down. So in future, the phosphate ore production may goes down. But very surprisingly, when we mine phosphate ore, and then this was, how to say, changed to the food or any industrial commodities, finally reached to our daily life, or meat or any other thing. During this starting point of mining to consumption, surprisingly, 80% of phosphorus is lost, wasted. It's incredible. We know soon it may start to decrease total amount of the phosphate ore production. But still, we in vain lost the phosphate ore about 80%. So this is a big dilemma or contradiction. So we have to meet these programs. So first of all, yes, most of them understand we have several programs about phosphorus. It's a very critically important material element for our life and society. And also very sadly, soon, the production of phosphorus, phosphate ore production may go down. Despite of this decreasement, we lost 80% of the phosphorus without using. So point is then how to meet these problems. So first of all, I explain what is a phosphorus, why it's so important, or what they are used. We can see this figure. Because phosphorus was used to produce the food, cheese, crops, peanuts, or even fish we must feed, and also like rice or wheat. This is a very popular immersion because phosphorus is very famous to use for the fertilizer. But if you see these pictures, phosphorus was actually used to produce these industrial commodities. All these contains actually this IC chips, semiconductors. So all these elements, like artificial satellite, also they have used semiconductor inside. So all these semiconductor was to produce semiconductors, we need phosphorus. Actually, high purity phosphoric acid is required. So without phosphorus, we cannot produce semiconductors. Consequently, no electric device. And also, this you can see this actually is supposed to the pharmaceuticals. So to produce medicines, we also need the phosphorus. So this simply shows in the illustration, mainly use this one, agricultural application, fertilizer and insecticide, but also the electronics and semiconductor production and pharmaceutical production. Phosphorus is a critically important element. And not only the use additives to the semiconductor or pharmaceutical product, phosphorus itself is a very interesting material. So mainly, most of the industrial product of phosphorus is this one, white phosphorus. Later, I may explain. about 20%, 10% of phosphorus was used to produce white phosphorus. Remains are for fertilizer. But not only the white phosphorus, we have black phosphorus, blue phosphorus, green phosphorus, red phosphorus, violet phosphorus, and fibrous phosphorus. Red phosphorus was used to match to fire. So all these one, actually, except red phosphorus, these are semiconductors. So phosphorus itself, if we have a different crystal structure, they were converted to semiconductors. So, but actually all these new phosphorus was theoretically expected, but only recently they are actually synthesized. So like most newest one, this one, two-dimensional black phosphorus, it's like graphene. We call it phosphorin. So phosphorus is today's topics is how to say the phosphorus problems, but also phosphorus itself is a very interesting material in future. So if you have interest, you may study of this one. So now I many times mentioned phosphorus is important for our life. So these food contains phosphorus: cheese, milk, meat, cereal, shrimp, and beans. So usually our body contains about 1% of the phosphorus of weight. So if a person with 70 kilograms, he has or she has about 700 grams phosphorus in their body. As an ordinary adult, usually they take 1 gram of the phosphorus and excrete it 1 gram. So it's balanced. Or take 1 gram and go out 1 gram. So the Korean population is about 62 million. So every day, about 23,000 tons phosphorus is required to maintain their life. Why it is so important? You may already know probably. It is called the so-called ATP, ADP cycle to produce energy for life. So ATP structure, it's a huge molecules. It consists of 3 parts, adenine, and also the ribose and triphosphate chain. So once water comes, they react and separate one of the phosphate. So during this process, they produce a huge amount of the energy. So this energy was used to maintain our daily life activities. So without phosphorus and also the nitrogen, our life cannot stand. So in this sense, phosphorus is critically indispensable element for our life. So previously I said we need 1 gram of phosphorus every day. So just look around how much amount of phosphorus contained in the food. This is a curry. So ingredient, meat, onion, potato, carrot, rice. So each to make a 1 person's curry, we need this amount of weight. So each 100 grams, it contains about 5.45 phosphorus. So overall phosphorus weight is about 72 grams. So if you convert it to the phosphate ore, because it consists of PCO5 and about 30%. So if you have a curry, you consume about 55 grams of phosphate ore. And interestingly, this one, previously I mentioned, we need 1 gram of phosphorus, but this curry already contains 72 grams, so very large amount, excess amount phosphorus we have. But all these phosphorus was actually did not stay in the body. It was through the kidney or evacuated. But if you have a problem with kidney, this was accumulated in your body and caused a very big serious sickness. So phosphorus was we take very much of that, but most of them is go out as a urine or some waste. So we now go to get some idea how important phosphorus to maintain our life. So now we go to the point of this seminar. Phosphorus paradox, we call it. It's a phosphorus of two phase I already mentioned. One is scarcity, the depletion of phosphate ore, and sometimes if we use too much, this create the work as a pollutant. So you can see this figure a bit busy, but you don't need to stick to the details. This was reported by EU. Every year, not every year, every 2 years, they report so-called the raw material criticality. The horizontal line indicates economic importance, and the vertical line is a supply risk. This one is evaluated by using some equations. If you have an interest, you can go to this subject through the web. You can easily access to this one. So for example, this I show the iron ore as economically very important, but supply risk is very low, no problem. And in this diagram, there is a two phosphorus. One is a phosphate rock and phosphorus. Actually, this is a white phosphorus. Phosphate rock actually very important, but just on the line. Several years ago, this was around existed here, no risk, but gradually going up, and maybe after several years, they may move to this upward. So this is very close to the supply risk. And phosphorus, white phosphorus is very important and also very high supply risk. So we have to manage to something to meet this risk. For example, the heavy rare earth metal is located here, light rare earth is here, so relatively close. So to get phosphorus is soon becoming very hard. So we now understand there are 3 problems about phosphorus issues. One is the depleting phosphate ore, already I show by the phosphorus peak. And another one is the supply risk of the white phosphorus. This one's later I'll explain the detail. And also another opposite side, if we overuse, this works as a pollutant. Actually, it is cause eutrophication. So first, I try to explain this overuse of phosphorus. I already mentioned 80% of phosphorus lost from the mining site to our daily life. The point is, if we use this farmland, fertilizer put in the soil, or livestock may produce waste manure, so they accumulate phosphorus accumulated in soil. So some of them was moving to the crop, vegetables, plant, and this one taken by ourselves as a food. But some of them, not all of them was not absorbed by plant. So then phosphorus is gradually accumulated. So it shows a phosphorus residual. And then this one is gradually diffused into the underground, or sometimes in the surface areas, it was run off by rain or flood, and also sometimes by the weathering. Many phosphoruses go somewhere, actually go to the river or sea through the underground water. So generally now we realize this accumulation. So we try to use fertilizer to compensate each other. I mean, the input amount of phosphorus should be go out. Out means like all should go to the meat or plant. But we are actually long history of agriculture. So more than several thousand years, we use phosphorus to get crop. So many phosphorus is accumulated in the soil. It's called the legacy phosphorus. Very unfortunately, it's very hard to control this amount. They are constantly, gradually diffuse into the underground water, and they, how to say, move to the lake or river or sea. So gradually, these phosphorus is accumulated in the water system. So typically now, about 40% of the phosphorus is coming from the farm, and 80% from our municipal sewage system. There, some amount, 80% of phosphorus goes into the sea. And naturally, we have in the mountain or any, how to say, hillside, they also contain small amount of phosphorus. They always, how to say, move into the sea, about 30%. But problem is this one. I already mentioned that we have a very long history of agriculture, so-called legacy phosphorus is contained. So about 40% of the legacy phosphorus gradually comes into the sea. Total amount of this one, in the sea, of course, there's a phosphorus in the sea was consist of this one, 40%, 8, 33, and 45. So it's as several assumptions, many researchers calculated the total amount of phosphorus transported from land to sea is about 0.2 billion tons. And very surprisingly, it is equal to the amount of phosphorus being mined every year. It's also 0.2. It's comparable. So actually, we dig out, mine phosphorus, the same amount was wasted in the sea. Of course, this is due to this legacy phosphorus mainly. So we have to do something. It's a phosphate ore is very precious. So most of them is wasted at this moment. Even if it was soon, it will be depleted. Actually, this kind of the phosphorus running flows in seas always occurs naturally without human activities. Like phosphorus-rich mountain due to weathering or flood or rain, they are always pass through into move to the river and finally go to the sea. And in land, animals' manure or plant, they are composed by the bacteria, and some phosphorus was also diffused into from soil to the river to underground sea. So finally, they reach to the seabed and gradually accumulated as a sediment. So due to some geological action, these sedimented layer is lifted up, becoming a mountain. So again, this was eroded, weathering, coming back to sea. So this from seabed to land to sea takes 10 million years. So if we can wait 10 million years, all these phosphorus, maybe we can recover, but it's actually practically impossible. So then very big problem takes place. If we, how to say, properly control the phosphorus flow in water system, it's actually nutritious materials, nutrition, phosphorus, nitrogen. So they can all living creatures happy to get this phosphorus and nitrogen, especially the plant. So this algae is a reasonable amount. So sunlight can pass through to the deep bottom of the system, and all these plants can provide oxygen. So they're very happy. But if too much, this is becoming the very sick, so-called becoming bloom. We call it algae bloom. So sunlight cannot pass through to the bottom. So all this one, photosynthesis does not occur. So they cannot provide oxygen. So all of them this system, oxygen is very decreased, so all of the creatures died. So it's we call the eutrophication. I prepared a short video clip so you can understand much more clearly. So you understand the essence of eutrophication. So it is not the exaggerated result. For example, in the particularly inland sea, there's no way to go out. So all these phosphorus or nitrogen is gradually accumulated. This is a Caspian Sea, especially this area. The huge amount of the algae was produced. So this area, actually, many of the fish has died, actually. They try to now recover, but still not so enough. So this was, if continues, we call the oceanic anoxic event. If the oxygen in the sea system is very decreased, all of the living creatures disappear. It takes place several times in Earth history. You may know we have 5 or 6 so-called mass extinction. Maybe this is very famous. Dinosaurs died, disappeared. In this case, probably mainly due to the meteorite. But in the early stage, about 5 billion years ago, 500 years ago, all sea living creatures has disappeared also. This was many researchers believe due to the so-called this one, anoxic event. Oxygen in the sea is this very decreased or becoming very acidic. So they cannot survive. So this is surely occurs if this situation continues. So 2009, Professor Rockström, Swedish, their group published a paper so-called planetary boundaries. Once they have classified into 9 sections, you don't need to stick to each items. But if you see this is phosphorus and nitrogen. Actually, this is reflects the Earth dynamic system. So if once the value reach to the threshold, becoming very unstable, the Earth system. So you can see already phosphorus. This is actually second level of threshold. Within this one, we can return. But phosphorus, nitrogen, and biodiversity is already excess and may reach to this very unstable level already. So we have not realized, but our Earth itself is somehow close to very unstable conditions. Very interestingly, if you see the climate change, it's a very safe situation compared by nitrogen or phosphorus. So compared by, we are very aware of and also very popular. I mean, that many people realize and many money was spent on the CO2 issues, but actually it is not reached the threshold. But the phosphorus and nitrogen already very dangerous situation. We may cross to the point of no return. Must be very careful. And this is their calculated result starting at 2009, now 2025. The initially only 3 is cross the stable level, but gradually increasing. Now 2025, 7 some the items classified 1 is already reached the boundary. So we have to do something. Actually, but it's not so urgent matter actually. If inflow of phosphorus from land to sea now already exceeds 11 million tons per year, if in this case it's trigger an oceanic anoxic event within next 1,000 years. The current rate is 22 million, almost 2 times. Especially, similarly, freshwater is also current rate is 40 million phosphorus flows into the lake, but threshold is only 62.2. This is also almost 2 times. So if we continue this situation within 1,000 years, our Earth system may collapse. So we have to do something. Unfortunately, developed country do something. We have strong regulation and also a lot of the technological, method to meet this problem. But unfortunately, the developing country, like Africa's country or South Asian country, they have no regulation. So many of the phosphorus runs into the water system. So this is not their own country's problem. This is our problems, because once this coming a problem, our system collapses. So we have to do something. Please aware of this importance. So now I show how our phosphorus issue is so severe, especially when it was overused. So now we move to another side, scarcity, depleting phosphorus ore. Because phosphorus is very important, still total amount of production soon may go down. So I already mentioned that this is a distribution of phosphate rock reserves. Morocco have occupied about 70% of phosphate ore was produced, deposited in Morocco, and other countries less than 5%. China or Brazil 5%, 3%. This is a phosphate ore production amount. Quite interesting in Morocco. Even if they have a 70% deposit, they produce only 70%. China, they only have a 5% of deposit. They produce 40% of the all over the world. And also the United States, they deposit only 1% of the all deposit, but they produce 11%. So huge. These countries are big agricultural country also. So they need a lot of the fertilizer. So this usage of fertilizer reflects this production. So this is a recent production change with year. Morocco is slightly increasing gradually. Other country also, but China very rapidly increased, but 2017 suddenly start to go down. Maybe this is due to Lehman shock. And if we divide by this one, by this deposit, by this production rate, we can estimate how long we can get phosphate ore. So Morocco, actually, if we continue the same production rate, maybe more than 2,000 years they can get. In the United States, maybe 2, 3, 4, 5, 6, 60 years. China also maybe 50 years. So United States, China, if continue this production rate, within 5 years, surely their phosphate will disappear. I already showed this one previously. This is a so-called peak phosphorus curve. This diamond point is actual production. And this, the brown curve, is simulation, depend on the researchers. This, I already mentioned, this might be moved somewhere, but anyway, this is the peak. So why phosphate mining amount is increasing? It simply reflects the population. This is actual production of phosphate ore. This is a population, human population. Actually, this is continued to increase. So they are almost comparable because to maintain the population, we need a food. To produce the food, we need a fertilizer. Fertilizer was made by phosphate ore, so increase the population. Phosphate ore production also increase. So at this moment, we expect population is also continuously increasing. So that we need a continuous increase of phosphate ore. But we already know this might be decreased. I forgot to mention, it's very important to realize this decrease doesn't mean the physically disappear. This decrease corresponds to the economically mineable phosphate ore amount is decreasing. So if you spend much more money or another technology is coming, so we can excavate this amount of phosphorus with low cost, they can not decrease slightly or maybe becoming mitigated. But anyway, at this moment, economically viable phosphate ore is decreasing. So then how to meet these problems? There are two ways. One is the demand side and supply side. Supply side was absolute amount of phosphate ore is going down, so we have to reuse actually. Or demand side, we can try to improve agriculture system, food chain system, or mining fertilizer to use effectively, even if at this moment impossible to mine, we try to get. So somehow manage to work on this one. Otherwise, we cannot produce food, especially in the developing country. Once usually, and also if phosphate ore amount production is going down, phosphate ore price goes up, then fertilizers price goes up, then poor country cannot buy, especially in the developing country, such as African countries. Then most of them face to starvation, so most people become refugees. So they go to another countries. So all over the world, society becoming very unstable. So phosphorus issue is not small issues. It's related to all of us. We have to find out the solution. So this is, we made programs. This is where phosphorus was used. You can see that about 82%, depend on net years, but actually 80% of phosphorus is used to agriculture side, especially as a fertilizer. And only 80% was used, actually, including this one. Most of about 10% was used for industry. So they are, how to say, not so much industry use. So they are not so competed so far. But recently, very big problem comes. It is the appearance of the electric vehicle. We expect electric vehicle manufacturing number will be rapidly increased. The electric vehicle was run by using battery. The battery needs cathode and anode. Previously, cathode materials mainly produced by using manganese, nickel, or cobalt oxide complex oxide. But they are also facing to depletion. So gradually, the cathode material will change to the Li lithium iron phosphate, LFP. So compared by the previous usage of the phosphorus in the semiconductor, the cathode is some particular size, I mean some amount of the volume they have or weight. So it requires large amount of phosphorus. Actually, to produce one electric vehicle, actually 10 to 20 kilograms of phosphorus was required. Huge amount demand. So this creates a big problem. They may compete with fertilizer production. So again, fertilizer price may go down. So it triggers social instabilities. Very sad. So to meet this program, we have to do something. So first, the solution is, one of them is phosphorus recycling. This one, reuse. And also another one is try to find another phosphorus resources, alternative of phosphate ore. So first we think about this recycle. So for this one, very famous book, Phosphorus Recycling, Recovery and Recycling, edited by Professor Otake. They are very kind, generous, so we can see, we can get the PDF product from this website. So if you have interest, you can go and download it. So when we think about the recycle, we have to think about where is the phosphorus at the final stage. So all these come from the sector, food, farmland, fertilizer, or chemical industry. And finally, most of them go to the reach to this stage. Sewage, sorry, it's a spelling miss. Sewage sludge, about 40 kiloton. Another one is this one, is come from the iron ore and concentrated into steel slab. And third one is soil. They are accumulated in the soil. So first, we think about the use of the phosphorus in sewage sludge. This is a phosphorus mass flow in Korea, the same. Finally, there is soil accumulation, sludge, and slag. So to recover phosphorus, I just I'll show you the video clip. So you understand how to recover phosphorus because this weight sewage system is so I briefly explain again. We get phosphorus from the phosphate ore and go to some plant, produce fertilizer. The farmer use this one to put it in the cropland, and we get food, vegetables, and we digest it and evacuate it into the sewage system. They come back to the water treatment system, and some such was actually dumped previously. But point is, stop this dumping. We try to recover phosphorus and we use. So we can make the closing phosphate loop. But so how to do that? This shows a sewage sludge after incineration. We get ash. This composition is something like this. This contains about 30% bits of fine. So compared by phosphate ore, it's very comparable, rather sometimes very large. But the point is, phosphate ore actually is a small amount of Fe2O3, alumina, and silica. But sewage sludge have a huge amount of SiO2, Al2O3, and Fe2O3. This composition, this chemical, these elements, these compound oxide make difficult to recover phosphorus. To recover phosphorus from sewage sludge, many processes was proposed. Strobite crystallization method, calcium phosphate precipitation method, some chemical extraction method, biological reduction method. And strobite crystallization method is most popular because they contain nitrogen and phosphorus. So these can be directly used as a fertilizer. So but there are so many processes to get strobite. It's a very busy figure, but you don't need to stick to the detail. And also this, for example, start from the wastewater, pre-treatment process, come to treatment process. There are several ways, 1, 2, 3, 4, 5, 6 ways, it's shown here, probably much more. And then treated one was put into this strobite crystallization process. It also several ways, chemical precipitation or electrochemical method. And finally, after this treatment, we can get strobite. So very many processes are existed. So this shows some typical, how to say, the phosphorus treatment, strobite treatment plant, lots of them. Most of them try to get strobite, but there are so many methods, PAR method, or phosphogreen, ample system, airflex, they put on the name based on their own favorite process. So why so many processes was used? Answer, quite simple. There is no decisive way. Many people try to use, and also depend on the sewage system localities. Someone is possible to use, but another one is not suitable. So there are so many processes existing. But one of the big problems is all of these processes is not economically viable. All are running in deficit. They cannot get profit. So this system plant is supported by local government subsidies. So very economically unhealthy condition. So we have to do something to get economically sound process we must develop. Otherwise, most of the company doesn't want to do it. So we're talking about the phosphorus recycling system. There are a lot of, but all of them was not yet reached to the acceptable level. And also another one is unused phosphorus resource. I mean the alternative of phosphate ore. It is already mentioned, this one. All of these origin is phosphate ore, but still some phosphorus is totally no relation with phosphate ore. It simply comes from iron ore. So if you see this figure, particle line is logarithmic. So this must be careful. So once this is a crude steel production amount, blue line is a phosphate reduction. This is the PO5 consumption. Phosphate reduction means they have a ore, phosphate ore production, sorry. So most of them is, they have, PO5 consumption is like all include fertilizer or any other phosphorus content compound. You can see there phosphate reduction was comparable. So they can use this one to produce. As Korea and Japan, we have no phosphate preparation. So it is very difficult to produce fertilizer their own because we have no phosphate ore. So must be all imported. But if you see this one, when you see this steelmaking slabs amount of PO5 in steelmaking slab, it's a huge amount of PO5 existed. Once we can recover this PO5, it is almost easily supply comparable to the PO5 consumption, much more probably. So this is very attractive phosphorus resources. And if you see the iron ore with phosphorus impurities, previously up to around 2000 years, their phosphorus content is about less than 0.07, but after 2000, the amount of phosphorus gradually increasing, now maybe reached 1.2 or 3. So amount was very increasing. So future, we may get much more phosphorus in steelmaking slag. So very interestingly, initially the very high grade iron ore only phosphorus concentration is about 0.05. And then through the blast furnace, big iron phosphorus increased to 0.12%. And through steelmaking process, all phosphorus is moved into the steelmaking slag. And their PO5 in steelmaking slag is increased to 2% to 10%. So from 0.0 to about 2%, huge concentration takes place. The problem is PO5 concentration in steelmaking slag is relatively low compared with phosphate ore or sweet sludge. But amount is so large. So we should somehow manage to recover this one. It's very challenging. So this shows us some comparison of each resource's merit and demerit. You did not, I think it's not so important. Point is this one. The phosphorus concentration, phosphate rock is very high. Phosphate slag also very high. But steelmaking slag is small. So this is a very big demerit. So we have to do something to recover phosphorus from steelmaking. Ordinary process may not appropriate. Several work was carried out to recover phosphorus from steelmaking slag. So this was done by Professor Kitamura's laboratories. You can see to start on steelmaking slag, finally go to the crude phosphoric acid. So many steps we need. So it's becoming very expensive. So to produce phosphoric acid can easy to get by using the phosphate ore. If we can try to recover phosphorus and produce phosphoric acid from steelmaking, cost is easily almost 10 times. So no way to apply. So definitely, certainly, we have to find out the way to very, very effective and economical recovering system. Very challenging. So now we talk about how to meet what is the program of depleting phosphate ore, and how to meet this program. Point is, probably we need the secondary phosphorus resources, phosphorus recovery from secondary resources. Another one, so now we move to another phosphorus programs, like phosphorus supply risk. So this was already shown. White phosphorus is important, but very under high risk. So this is white phosphorus we made. It's not white. It looks like a yellow, but this surface was slightly oxidized. So it looks like color becomes yellow. So this is very dangerous materials. If you put on the air, easily ignite and start to burn. So usually it was kept in the water. White phosphorus usage in industrial product. You can see these all commodity contents was produced by using white phosphorus. Actually, white phosphorus used to produce semiconductor device. Much strictly speaking, precisely speaking, these one produced by using ultra high purity phosphoric acid. And ultra high purity phosphoric acid is only produced by using white phosphorus. That's why this one, white phosphorus, is very critically important to produce semiconductor. And also the very advanced and sophisticated pharmaceuticals are produced also using the high purity, ultra high purity phosphoric acid. That's why to produce this one, medicines, we also need the white phosphorus. Very unfortunately, at this moment, there is no process is not existed to produce high purity phosphoric acid from any other phosphorus compound. So only possible approach is use white phosphorus. And then what is the problem supply risk? Actually, white phosphorus is produced only these 4 countries: China, USA, Kazakhstan, and Vietnam. That's only 4 countries can provide. Any other country cannot. So once they try to control the export, most of the imported country suffers so much. As already shown, only 4 countries produce white phosphorus, and China consume most of them by themselves. US also. Kazakhstan, most of them imported to European country. And Vietnam provide white phosphorus to Asian countries. So India, Japan, Korea get white phosphorus from Vietnam. So this is some white phosphorus flow, trading flow. West Asia, China, most of them consume all of them by themselves. Trump provide South Korea, Japan, and India. And European country get white phosphorus from Kazakhstan. USA actually also consumes most of them. Some of them go to Canada. This process is actually Monsanto. They provide white phosphorus to Monsanto to produce insecticide. This is actually US company. So all of them actually consumed in the US. Why only these 4 countries can produce white phosphorus is simply due to their producing process. White phosphorus is produced by using the electric arc melting system. They put on the phosphate ore and also the carbon, and using this arc furnace heating system, all this phosphoric acid is melted, and due to by the carbonic reaction of phosphate ore, they are reduced to P4 gas. So they are also P4 gas come from here, and then condensed by cooling, you can get liquid white phosphorus. And problem is, one of the problem is this one. Generally, phosphate ore contains very hazardous elements such as aluminum, radon. So once they are produced, they also, as a byproduct, slag contained with these hazardous elements was produced. So this is a very big environmental burden. So after treatment of this slag is tremendous burden for us, or producers. So for reaction like this, we can to get the P4, this reaction takes place, and again to get the white phosphorus about 14,000 kilowatt to produce 1 ton of white phosphorus. It's a huge amount of electric consumption. And slag contains radioactive element and also hazardous element. So to treat this one, make it without any harm, is cost lots of. So countries with high electricity price, and also if country has a very severe, tough regulation, environmental regulation, this country cannot produce white phosphorus, because at this moment only this method is a possible way to produce white phosphorus. So if we are free from white phosphorus, independent of the 4 countries, we have to make an innovative white phosphorus production process, which should have this following character. No use of phosphate ore. If we once use phosphate ore, it also depends on the countries. This must be low energy consumption, otherwise cannot produce, and also low environmental burdens. So, particularly Europe, they are very, from these 20 years, they try to innovate, invent the new process, try to develop new process to produce white phosphorus. They start from the so-called in the curve to decomphos to flash hose. Currently, most recent one is named flash hose. Decomphos is actually quite simple. This also working and using in a different way, but anyway, it put on the this source raw material is as a sewage sludge. They put on sewage sludge and coke, And then using the, induction heating system, all this sludge was melted and reduced, and P2O5 in sludge was reduced to P4 gas. Then it was recovered. So there are several programs. They modified, and finally come to this partial system. This project was finished this year. So you may get some idea of the thresholds. Quite interestingly, this project was supported many companies. Actually, it was initiated by University of Stuttgart, but in US, many companies support to develop this one. So reversely speaking, so to get phosphorus without the did not depend on the import is very critically important for Europe. We also, Japan also developed new white phosphorus production system. It was called the RINFOS. It's a totally different. We use crude phosphoric acid as a raw material. It was produced by sewage sludge. And this liquid phosphoric acid is by the carbon reactions. We produce phosphorus gas and CO and hydrogen. So phosphoric acid is provided by droplet onto the top of the packed bed of carbon. Temperature is around 1000, and then decompose and reduced and becoming the phosphorus. And by cooling, they are becoming the liquid droplet and go down and collected at the water vessel. So initially, we start this small large scale equipment, and now we develop this kind of demonstration plant. So last year, we get about 15 kilograms per day production. Now we are try to construct with about 100 times larger pilot plant now. So our future plan is, of course, we can get from the crude phosphoric acid using as a raw material and produce yellow phosphorus. This one is essentially already established. Problem, not problem. The next stage is somehow manage to produce low-cost crude phosphoric acid from secondary domestic phosphorus resources such as sewage sludge or steelmaking slag. But I already mentioned this process we can do if we pay much. But the point is how to make crude phosphoric acid with economically reasonable cost. So we are now starting this project also by support of the government. I very hope, but still it's not very challenging, but I hope within several years we may manage to develop the new phosphoric acid process. I already mentioned there's a lot of the process. All of them was not economically viable. So we have these old previous systems may not be useful. We have to do totally innovative process. We must develop. Actually, we're doing this one by using the organic solvent. I hope it can work. Okay, so now our final target is, because phosphorus is very precious materials, and total amount we can get will be soon gradually degrading. So point is future to meet this program, we have to develop circular, so-called circular economy without phosphate ore or phosphate. Phosphorus must be make this loop. Previously, just get and dumped. At this moment, most of them is somehow not 100%, but the reuse economy. Some of them return to again, but it's not sufficient. So we have to enhance this system. But to make this circular economy, there are big problems. Actually, phosphorus circular economy, phosphorus mining and fertilizer production using agriculture and get the food, and wastewater was treated here, and then another wastewater treatment plant get something, phosphorus recover and go back to through this water plant. We get phosphorus recovery, recover the phosphorus, and then produce biofertilizers. So this circular may be possible if we can start concerning the secondary phosphorus resources. Once it's effectively recover the phosphorus from the sewage system, maybe for this one we can. But problem is this one. We've already mentioned many of the phosphorus is accumulated in soil. So recovering soil is phosphorus from soil is very, very difficult. Otherwise, we cannot complete this circular system. So this is an element in the Earth's crust. So all element is surface of the soil of the Earth is consists of silica and alumina and iron oxide mainly. So very unfortunately, iron and aluminum is very easy to form iron phosphate and aluminum phosphate, especially around this neutral and weak acidic region. So once we provide the phosphorus, there, because soil contains a lot of the aluminum iron, so they form this one. So they were not used to by plant. They're actually inorganic phosphorus, they stayed in the soil. Of course, take a very long time to decompose, but apparently it was very stable. So to improve to avoid this formation, there are several ways how to mitigate phosphorus loss in soil. One is the soil improvement, so-called biostimulant we can use, and vertical farming. So phosphoric acid is very stabilized by the aluminum and iron. But if we put on the so-called biostimulant like fulvic acid or humic acid, they make chelation. Chelate action takes place. So all these humic acid, how to say, separate iron and phosphate. And then once they are, how to say, bond was separated, this one easily absorbed by the plant. But problem is fulvic acid and humic acid is very large polymer structure it has. And it's very hard to produce, synthesize. Only can be get from the humus or compost by extraction. So we cannot produce large amount of that. So this is a very limited use at this moment. I very hope future this one is biostimulant was manufactured under mass production process. Then we can improve the soil efficiency, and we don't need to put in a lot of the fertilizer in the soil. Another one is vertical farming. You may not, so I just show the simple short video clip. So you can see in your vertical farming, all these land use, water consumption, yield is okay, pesticide no need, weather dependence also very small. So CO2, this is very ideal farming system. So something like that, we can use water nutrient, how to say, the nutrient solution. The water contains nitrogen or phosphorus. We can provide by, in this way, way, or can provide by mist or fog. The water contains nutrient element. So in this case, we don't need phosphorus. No soil is existed. So just exactly required phosphorus and nitrogen and potassium can provide. So this is not just experimental idea. So already there were many places this was in practice. Like this huge amount of the factory was running. This is some kind of emerging in future. And this one is already running. They call the Stanica, world's largest vertical farm in UAE. They produce 10 million tons per year of vegetables. And this one is soon, maybe 2029, they will start. They call World Food Building. It's a Linköping in Sweden. So this is a very real factories. So far we explained many aspects about phosphorus issues. So point is, then what can we do about phosphorus issues? I already showed this one. Point is, some are managed to reuse on supply side and also use another alternative like a steel making stuff, and also try to improve the efficiency to use mining, fertilizing system, agriculture system, food chain, should not waste lot of food, and changing diet, maybe decrease the meat, so you should not eat too much bulgogi. So as to make this kind of reuse, we need, this is not so sufficient enough. Development so-called phosphorus refinery is very important. Phosphorus refinery means technological system for extracting and reusing phosphorus from phosphorus-containing waste and phosphate compound. So we need development of this field. So this is the end of my talk. I very hope most of them realize how important phosphorus issues. And phosphorus issues have a lot of aspects. So many of them can make some contribution to this program. So I very, very hope all of you taking part of this to solve these phosphorus issues. Thanks so much for your kind attention.